Firstly, please sit down. Secondly, no, not quite. Okay, it's true that both give you an isolated environment where you can run an OS, but containers are quite a bit quicker to spin up and typically less resource intensive. If there was a scale with VMs on one side and normal native applications on the other, containers would sit somewhere in the middle. Virtual machines are pretty much just tricked by the host's hypervisor layer into thinking they're actually running on real hardware. Containers, on the other hand, are more friendly with the host system and just emulate a minimal file system, while piggybacking resources by sharing the host's kernel. The kernel is no, not that kernel. Close enough. The kernel is the core of any operating system. It's the bridge between what the software asks for and what the hardware actually does. It's responsible for all sorts of critical low-level tasks like CPU and memory management, device I/O, file systems, and process management. So, how does this all help us as developers? Well, now that we have an OS at our fingertips, trademark, we can work in several different environments at once without having to really compromise anything on our local machine. For example, we can maintain an old app using the OS and package dependencies it was originally built on top of, while also being able to use bleeding edge tech for our next multi-million-dollar project, without having to worry about any conflicts in doing so. We're also now able to put an end to the "it works on my machine" problem, which is a pretty common phrase to hear in the tech industry, unfortunately. Because a container is essentially a full OS at its core, you can be sure that wherever it runs, you're going to get the exact same environment, whether it's on your colleague's machine, your server machine, or somewhere in the cloud. Now we've got the basics out of the way. Let's see how we can make a container of our own.